Good morning, good afternoon, and good evening, and thank you for joining us for Session 2 of Informatica Cloud Tech Tuesdays. Today's session is going to focus on big data initiatives with cloud integration, specifically focusing on the Amazon RedShift flavor of big data. We have with us today Vijay Narayanan from our Cloud Product Management team, and Vijay is really the driving force behind a lot of our new connectors that have come out. He's been with Informatica for over 8 years now, and it's a pleasure to have him on today's show to talk about Amazon RedShift. So let's go over today's agenda. So we're first going to go over what big data is and why it's so strategic to your organization. And then we're going to delve into what big data really means. Then we're going to go into some of the partnership behind Amazon RedShift and Informatica Cloud, and Vijay is going to go into a detailed demo. After that, we'll wrap up with some tips for success when using Amazon RedShift and have some of your questions and answers. So please use the chat panel provided to ask any questions you may have throughout this particular session. And then we're also going to talk a little bit about next week's Tech Tuesdays session. So when it comes to big data initiatives, Gartner really finds that over 42% of IT leaders are either planning on investing in big data this year or they already have invested in that data. And these sorts of initiatives are really varied across different industries. So for instance, when you look at the banking and security industries, it's no surprise that they have some of the highest volumes of data. And when it comes to the velocity of data, it moves rapidly across several data sources, which is why some of the most earnest users of big data solutions. It's also important, as you see in this particular chart, the variety of factors that go into an overall big data solution. Obviously, volume and velocity are pretty important, but even more important are the variety of different data sources, the cost savings when you're not using the amount of hardware that you need to, as well as other software that you may need to integrate with. So it's really interesting to see the different industries that are adopting big data and where they are in the adoption cycle. Obviously, communications and media services are pretty high up, and the government has also started adopting a lot of big data initiatives. So when it comes to big data, what does it really mean? Well, the name is actually a little bit of a misnomer since there's no single product that can define big data other than the fact that they all deal with large amounts of volumes. For instance, people think that when folks say big data, it generally means Hadoop. But Hadoop is just one of the many flavors of big data. There's a lot of different Hadoop-based variants of big data such as Mahout, Scoop, Chukwa, to name a few. There's some NoSQL databases such as MongoDB and CouchDB. And there's databases in the cloud that deal with big data such as Amazon RedShift and Google BigQuery. And just because there's so many different flavors of big data, the focus of today's session is going to be on Amazon RedShift. So because there's a lot of technologies, folks sometimes ask us, what technology of big data should they use to accomplish their objectives? And the answer really is to focus on the particular use case that you want to achieve. And that use case will best determine what flavor of big data you want to really use. So we see amongst our customers a different variety of use cases, ranging from data warehousing to predictive analytics to online transaction processing, machine data. And this is just a small sliver of use cases when it comes to big data. And today's use case, though, since we are focusing on Amazon RedShift, we're going to be focusing on the data warehousing aspect of it. So what have we done with Amazon RedShift? Well, earlier this year, Informatica and Amazon RedShift announced a partnership in order to have more cost-effective data warehousing to the masses. And the value proposition behind this is, as you know, with Amazon RedShift, because it's in the cloud, are able to provision a lot of database nodes on demand without going through the complex and complicated process of provisioning individual database servers and preparing them to receive large volumes of data. And because of this, you can really start your large-scale data warehousing projects a lot sooner. And that results in a lot of cost savings, because what would normally cost you a lot of money to use on-premise databases for data warehousing can now be offloaded into the cloud with Amazon RedShift for a lot more cost-effective type of big data processing. And you can find more information at www.informaticacloud.com/Amazon-Redshift. So with that, I'm now going to pass the reins over to Vijay Narayanan.
So I will start with looking at the Redshift console, because if you're going to connect to Redshift, you need the information that is there. So you typically need the JDBC URL, which you can see here. You also need the ODBC information, which is given here. And you need to make sure that the Redshift security group is actually enabled IP address. So I have a bunch of IPs because I'm accessing it from multiple machines. But typically, you need to make sure that the machine running the Informatica Cloud Secure Agent is given permissions here so that you can actually connect. Now, Redshift, to connect to Redshift, depending on whether you're reading or writing, you have to create different connections. So we have come out with a connector that does bulk write into Redshift, while the read is through a ODBC connector. Now, if you are writing into Redshift and you want to use the connector, so I'm going to just go, I've created a connection here. I'm going to go ahead and pull up the connection parameters. We need our a username and a password. So these is for a Redshift database user with appropriate privileges to the tables you're trying to access. So typically you would need select, insert, update on that table. You then need the connection URL, which is the JDBC URL, which shows up when you go in here. And you also need the access key and the secret key of a user who has read and list bucket privileges on the S3 bucket that you're going to use. So the Redshift connector essentially writes out CSV files into S3 and uses Redshft's copy command to bulk load into Redshift. So the S3 bucket pretty much has to be in the same zone as the Redshift cluster. And then you need to specify the type of cluster you're using and also the number of nodes in the cluster. The number of nodes is required because for best performance, the number of files that we write into S3 needs to be equal to the number of nodes, and the connector automatically splits up the data into the number of files which is specified in this number of nodes. So this is a Redshift connection configuration. So if you go ahead and say test connect, typically it will show that the connection test is successful. And then if you're going to read data, you need to create a ODBC connection. You can download Amazon's Postgres ODBC driver, the 32-bit driver. So I think later in the presentation, there's a link to that ODBC driver. And if I were to access my machine where my agent is running, you can see that I have created a ODBC connection to my database. I've got the server name, the user, the port. So this is information that is available when you look at the ODBC URL in the Amazon console. You can look at the ODBC URL again. You can see the server here. Then they have the database. You have the the UID of the user. Of course, they have the port number specified here. So you need to get that information and create a system DSN in the machine in which Informatica Secure Agent is running. So once you're done that, you're pretty much set up to connect to RedShift. So I'm going to go ahead and create a data synchronization task to synchronize flat to RedShift for demo purposes. But of course, it can be any of the other data sources that Informatica Cloud supports. So we're going to call it something here. So when you pick an operation for RedShift, it needs to be either insert or upsert. These are the only two operations that Amazon supports, and upsert is supported by creating a staging table in RedShift and then calling upsert on it. So I'm going to go ahead and choose insert here. So going forward, I'm just going to pick a source. In this case, this will be a flat file source. I already have a flat function. I'm going to pick my customer data. So I got customer data from some system. I want to push it into RedShift, a typical data warehouse type of scenario. So the target in this case will actually be RedShift. So I'm going to pick my RedShift target. So what you will see is a bunch of tables from RedShift. So I'm going to pick this particular table I created for demo purposes. So while this is coming up, so if I were to go into my SQL workbench, which is the interface for doing the SQL operations and RedShift, I can actually run a query here. You can see that it's got no data. Okay, let me go ahead and finish up this task. I'm not going to add a filter here. I'm just going without filters. And then you can do the field mapping here. So it's already auto-populated these fields based on the name. I'm going to go and drag the internal ID field from this guy here to the primary key. Customer ID is my primary key. Then you roll down to the bottom here. You can see some additional parameters. So first is the S3 bucket. So as I already said, the S3 bucket needs to be in the same zone as the RedShift cluster. And then there is a staging file location. So in my case, I just have so this is a local folder in which the CSV files are first written out before upload into S3. And then we have the batch size and the error threshold. So the way the error threshold works is that if the number of errors is greater than the threshold, then that particular copy from S3 to RedShift actually fails. So the way we have designed this is that you can split up your data into batches so that if there is a failure, then it's just that batch that fails and you don't have everything failing. So if you're loading 100,000 or even 1 million records, then you do not want the whole thing failing. So you can break it up into batches, but of course there is a trade-off in terms of performance. And so that is for the user to sort of figure out based on the particular situation they are in. So that's how we have thought of this. And then I can go ahead and run this guy. So to give some, so while this is running, I think I'll check. There's some issues here. Yeah, so you can see there is no data as of now. It's an empty table. Kicked off the load here, and the load is running through. So, based on our internal testing, we have seen something like half a gig of data. There is 3.5 million rows load in about 7 minutes. So that's the kind of performance which you've seen based on some testing which we did. So while this is running, let me go pull up another task which I pre-created. So typically what I showed you is a straightforward load, but in general with data warehousing type of situations, what you would like to do is do some additional things, for instance, lookups. So what you could do if you're going to do a lookup into RedShift, so a scenario could be that you're populating the some kind of master data and you have an ID and you want to get a name, or you're populating maybe some amount of transaction data and you want go ahead and get the customer name, product name, things like that. So what you would do is put in the lookup here, and then in this case, you would choose the ODBC connection that you've configured for Redshift, because the lookup is through the ODBC. And again, you can see pretty much all the tables that you have here, and then I can pick one of them and then go ahead and configure the lookup. So that's how this is going to work. So I got a bunch of, I can choose whatever field here. I can choose the lookup field here, and then I can then choose the output field and do a lookup. So this is a lookup into Redshift so that you can take care of a typical data warehouse loading type of scenarios. See if that's finished. Okay, we did go through right now, and let me go ahead and connect here. So you can see all these rows got loaded here into Redshift. Okay. So that's pretty much what I had to show from a demo perspective. I'm going to transfer the control back to Ashwin to take this forward.
So let's look at some of the tips for success when using Amazon Redshift. So as a very first step, make sure that you download the SQL Workbench, and you got to go to basically www.sql-workbench.net. And also make sure that you add your current IP address under security groups when you're logged into Redshift. So Amazon Redshift has some very robust security features and will only allow you to access it if you add your current IP address to that account. And then once you've done that and you've now logged into Informatica Cloud, you need to create two connections, as Vijay showed earlier in the demo. To write, go ahead and use the Informatica Cloud RedShift connector, and if you're reading, then use the ODBC driver. Make sure that you download a 32-bit version of the driver, and here's the URL for you to be able to do that. Also, you want to make sure that your Redshift cluster and your S3 bucket are in the same availability zone. So let's say you're using US East. You want to make sure that the cluster and the bucket are in US East, or if you're using US West, that they're located in that particular zone. So now it's time for some Q&A, and please do go ahead and enter your questions in the chat panel provided. We already have quite a few questions here, so let's go through each one of them in turn. So, Vijay, the first question that we have from our attendees are, what should their optimal batch size be in relation to the maximum number of errors? So in the demo earlier, you showed a screen where you're able to set the batch size, and you're also able to set the maximum number of errors before either the entire job fails or succeeds. So is there some kind of optimal batch size that should be set?
Yes. So the batch size depends a lot on specific customer situations. So one thing that determines is, because you could set the batch size to be the complete data set. So if you're loading 100,000 rows, you could say my batch size is 100,000 rows. But then there is a risk that you may fail the whole batch just because you have too many errors. So one thing to make sure is that how confident are you of your data quality. The second thing is, of course, if you're going to specify the batch size to 100,000 rows, then we would write out larger files and try to load them in one, instead of batching it, we will load in one shot to S3. So that may consume additional resources on that machine. So that's something to be kept in mind. Pretty much, I would say batch size that is sort of 1/10 the number of rows you're trying to load is probably it's probably best, because too small a batch would definitely result in deterioration of performance. Okay,
great. So the second question we have here is about actually connecting to Redshift itself. So the question says that why is it that when we connect to Redshift, as far as writing, they can use a RedShift connector, but as far as reading, they're only able to use the ODBC driver?
So for writing, Amazon has essentially come out with this API, which, is, as you've seen, is essentially a bulk write. We write files into S3 and just load it into RedShift. While for reading, right now, Amazon does not have any such API, and the recommendation is to use either ODBC or JDBC. And of course, we have ODBC out of the box in Informatica Cloud, and so we are using ODBC to do that.
Okay, great. Another question that we have here from our attendees is about loading data from separate clusters of on-premise databases into Amazon RedShift. So this particular user has different clusters of SQL and Oracle databases, and they want to do lookups from one database into before loading the data into RedShift. So will they be able to do this?
Yes, they will be able to do lookups on databases and also on pretty much every other application, SaaS application or on-premise application that Informatica Cloud actually can connect to. So they can do a lookup on anything they want to.
Okay, awesome. Another question that's come up here is about pricing for Amazon RedShift. So essentially, Amazon RedShift is a cloud connector, so it's going to be priced similarly on a subscription basis, similar to our cloud integration service. So please do contact your account rep for more details around that. And the last question that we'll take for today is about other big data connectors. So we do have other big data connectors also in production. Various flavors of Cloudera as well as Hortonworks. And if you go to the Informatica Marketplace, you will be able to look for those types of cloud connectors as well. So now, let's go towards some of the next steps. So it looks like there's obviously some interest from the call today in trying out the Amazon RedShift connector. So please do get in touch with your account manager to enable this connector functionality within your Informatica Cloud account. And then a second thing you want to do is join the Informatica Cloud community, where folks like yourself will be discussing not only Amazon RedShift, but all the different types of Informatica Cloud integration functionality and other connectors. And next Tech Tuesdays is going to focus on SAP connectivity. So very similar to how we showed the Amazon RedShift connector and how simple it was, we're going to look at simplifying connecting to SAP. So that will be taking place next Tuesday at 8:30 a.m. Pacific. So that's all from us today. Thank you very much for attending this session of Tech Tuesdays. Join us again next Tuesday at 8:30 a.m. Pacific. Thank you.